Section 2.4 is the first day that we are going to be working on application problems. Our objective for this is to solve application problems using trig functions and select the best method to solve the problems. So our first example says the two equal sides of an isosceles triangle are each 24 centimeters. So the first thing I'm going to do is I'm going to draw that. Then it says if each of the two equal angles measure 52 degrees, and remember in an isosceles triangle, the equal angles are opposite of the equal sides. They want us to find the length of the base and the altitude. So remember all three angles inside of an isosceles triangle add up to, or any triangle, add up to 180. So these two angles add up to 104. So if we need that top angle, it's going to be 76 degrees. And that's for the full angle. Okay. And they want us to find the length of the base, which would be this entire distance here. And then they also want us to find the length of the altitude, which is that dashed line that I drew there. If you remember back to geometry, an altitude forms a right angle with the base, but it doesn't necessarily cut the base in half. So we're going to have to find three different distances here. We're going to have to find the height for the altitude, and then we're going to have to find both lengths of the base to make sure that we have the full length of the base. So if we start with just this triangle on the left side, we can figure out a few of those distances. So for that triangle, we know we have x here, the height there, and this is 24 centimeters, and our angle is 52 degrees. So if we were to solve for the height first, that's our opposite side, and we know the length of our hypotenuse. So we're going to go ahead and use the sine of 52 degrees equals h over 24. That gives us enough information to solve for h. Just grab a calculator here. There it is. So I'm going to type in 24 sine of 52, and that will give us our height, which is about 18.9. Now we can also find x. So x is our adjacent side. So this time we're going to use cosine of 52. And I'm going to stick with the hypotenuse because that's the one that they gave us the measurement, so it's an exact value. So that'll give me the most accurate answer for the value of x. So again, for this one, we'll multiply both sides by 24. And then we can type everything into our calculators. And this side is about 14.8 centimeters. All right. So that gave us our height, the length of the altitude, and it gave us part of the base. Now, if we look at our two triangles that we have, they both have the same height. They both have the same hypotenuse. And they both have two congruent angles. Now, we just need to figure out if y is going to be the same as x. And there's a very good chance it will be, because if we look at this, y is going to be our adjacent side. We're going to have our hypotenuse of 24, so we're going to have to do cosine of 52 equals y over 24. So we'll end up with the same value that we did for x, and that's going to be equal to y. So our total length for our base is just going to be that value times 2. So we'll take 14.8 times 2, and that gives us 29.6 centimeters. So that's just an example of using our trig ratios and our trig functions to find missing sides of a triangle, even if it's not a right triangle. We can use information to form right triangles to find the missing measurements. Our next vocabulary word is angle of elevation. An angle of elevation goes from a person's eye line, and then they're looking up. So the example I usually use is they're looking at the top of a tree or something, or a building. Here's my kind of poorly drawn tree. But angle of elevation, you're always going to be looking up towards something, or looking up at something in the sky. And then angle of depression, this is when you're standing on a building or in an airplane and you're looking down. So this is from your eye line, but then you're going to be looking down at something that's most likely on the ground, like another person that you're waving to or something. So that's what an angle of depression is. So they do go in opposite directions, and you will need to know how to draw diagrams when you're told there's an angle of elevation or an angle of depression. And they also use the vocabulary word line of sight. That's usually this line that they have where you're looking. So your line of sight. And they might use that vocabulary word in different problems. Alright, so example 2. If a 75-foot flagpole casts a shadow that is 43 feet long, so let's draw our flagpole. Here's my flag, and here's my shadow. Sorry, it's not a straight line, but that is 43 feet long. And we know the height of the flagpole is 75 feet. They want us to find the angle of elevation of the sun from the tip of the shadow. So here's the tip of the shadow, and our angle of elevation is going to go up and past the flagpole, but it's going to go through the top of the flagpole, and it's going to be where the sun is. And we are looking for this angle down here, the angle of elevation. So this is where our inverse functions are going to come in. We have our opposite side and our adjacent side. So for this, we are going to end up using our inverse tangent. And when you use inverse tangent, you're still going to put opposite over adjacent here. And that's going to give you what your angle is equal to. So for this one, we're going to do inverse tangent of 75 over 43. And that's going to tell us what our theta value is equal to, or our angle of elevation. So 75 divided by 43, and that's going to give us an angle of about 60.2 degrees. And that's our answer. Don't forget to label your answer with degrees. Okay, another example. A man climbs up 213 meters up the side of a pyramid. So if you think a pyramid is a slanted slope, so this person over here climbed up a distance of 213 meters. Actually, you know what? He should probably be at the top of the pyramid. Alright, so there's the person at the top of the pyramid. And it says that he went up 213 meters up the side of the pyramid and finds that the angle of depression to his starting point, which would be probably at the bottom. So I'm just going to label that SP for starting point. And his angle of depression from up here to his starting point is 52.6 degrees. And these are always going to be forming right angles here. I forgot to mention that, but we will always have right triangles that we can form when we're using angles of depression and angles of elevation. So using that information, they want us to figure out how high off the ground he went. So from the person, we have the angle we're using. Our height is going to be our opposite length, and the distance he climbed is going to be our hypotenuse. So this time, we're going to use our inverse sine function, which is going to be opposite over hypotenuse, and that's going to tell us... Oh wait, I'm sorry. We don't need to use the inverse. We're not looking for an angle. So we're just going to use regular sine. Sorry about that. So we're going to have 52.6 degrees equals our opposite length of x over 213. Now that we have that, we can go ahead and solve. And type it into our calculator, 213 sine 52.6. So the distance from his starting point is going to be about 169.2 feet. And that is the distance that he is off the ground. Okay. So the next part, this one you are going to have to look at a picture that is in your textbook. And I'm sorry, I forgot to include that. So if you just open PDF on Schoology or your actual textbook, you will be able to see the diagram of the map. And there isn't a problem like this on notes, so it is good that you get this example, or sorry, on your homework there will be a problem. So make sure that you get this example copied down. Alright, so we're in section 2.4. Alright, so this is the map that we are talking about here. So, for this, it shows the topographical map we mentioned in the introduction to this chapter. So we kind of skipped that part. But for this, suppose Stacy and Amy are climbing Bishop's Peak. Stacy is at position S, and Amy is at position A. And they want us to find the angle of elevation from Amy to Stacy. So to start off with, I'm just going to take a screenshot of this and insert it into my OneNote. This will be in semester 2, teacher only, chapter 2 materials. Okay, and then. And let's go get that. Let's copy that. Sorry about the wait for this. I did not realize I did not have that picture in there. There we go. That's not what I wanted to do. Paste. Okay, so now we have our picture. So we've got our map, and they want us to find the angle of elevation from Amy to Stacy. So they already did the measurement for us. They are 3.8 inches apart. So if we use our key down here, we know 1 inch is equal to 1,600 feet. And also, they tell us that the contour interval is 40 feet. So what that means is the distance going up and down between each line here is 40 feet. So the elevation between Amy and Stacy is 1, 2, 3 different lines. So going up and down for the elevation, we would take 40 times 3, which is going to be 120. And we also know that they are 3/8 of an inch apart on the map. So we're going to have to take 3/8 inches times 1,600 feet over 1 inch. By doing that, we get rid of our inches unit, and now we're left in feet. So if we simplify here, divide this by 8, that'll be 200. So 3 times 200 would be 600 feet. And that is going to be the horizontal distance. What they want us to find is our angle of elevation here. So again, we have our opposite and our adjacent side. So we're going to use inverse tangent of 120 over 600, and that's going to give us our angle. So we'll go to our calculator and type that in. Oops. Divided by 600. So our angle of elevation is going to be about 11.3 degrees. And that will be our theta measurement. So use this information and go ahead and complete the homework assignment. Then we will go over any questions that you have on this next time we have class. And you can always email me if you have questions, and if you have anything else, just let me know.